Good, very nice. But we won't worry about that now, okay, guys? Like you'll notice that pattern eventually on your own if you haven't already. Expand and evaluate. Okay, are you guys comfortable with multiplying fractions? I have a feeling you are. Okay, good.
I already understood how to multiply fractions, but I don't want to leak it because this is just, you're the instructor.
Yeah, I mean, everyone's at different levels. I honestly, guys, I don't know which level you're at. Okay, so who wants to actually, you know what, let's try something else. Would anybody like to raise their hand? Catherine, birthday girl, would you like to do this question for me? Would you like to help me?
I don't understand.
Okay, so let me help you out, okay? So look, here we have a power. This is called a power. Can you tell me what's the exponent of this power? That's the little number.
3.
Yes, and what's the base of this power?
1/3.
Excellent. So if you had to expand 1/3 to the exponent 3, otherwise known as 1/3 cubed, what would that be?
Wait, can you repeat that again?
How do I write this in expanded form? What does 1/3 cubed mean? It means
times that by 3.
Oh, that's no. So don't do 1/3 times 3, but that's close. You do 1/3 times 1/3 times 1/3. Okay, do you see that? Look, because this is a 3, that means you have to take the base, which is 1/3, and multiply it 3 times.
Times the number?
Exactly. The little exponent tells you how many times to multiply the base. Right? Look, try this one for me. Everybody, I know some of you know this, but let's just wait for a few people. Catherine's brave enough to say she doesn't know it, so let's just help her out here. Let's say I had 3 to the 5.
Wait, is the answer 1/3?
Oh, close. Look, how do you multiply? You did 1 times 1 times 1, which gives you 1. And then you do 3 times 3 times 3.
Oh, yeah, I forgot about that.
Yeah, you forgot the last 3, which is 27. But Catherine, let me just do one more thing with you, and then I'll let you just pay attention. See this example here? I have 3 to the 5. 3 is the base, 5 is the exponent. What does that mean? Like, how would you write that in expanded form? What does it mean, 3 to the 5?
You do 3 times 3. 3. So 3 times 3 times 3 times 3 times 3.
Yeah, awesome. That's 5 3s, right? 1, 2, 3, 4, 5. And then you can use your calculator to figure out what it is. Or you can just use a piece of paper.
Is it 15?
No. 15 is 3 times 5. 3 times 3 times 3 times 3 times 3 is a lot more than 15. Who knows what it is? I'm going to use my calculator. Did you guys use your calculator?
I don't have a calculator unless it's Google.
That's okay. 3 exponent 5. Yeah, definitely not 15. It's 243.
I have to estimate.
Yeah. Thanks, Alan. Okay, let's clean this up a bit. Is there anyone else that's having trouble? That helped, right, Catherine?
Can you repeat that again?
Did that help you?
Yeah.
Okay, good. Oopsie, one sec. I'm going to clear this. That's so messy. Okay. Let's see. Would someone like to raise their hand if they want to use their mic? Let's try that because sometimes it gets tiring to write your answer. Raise your hand if you want to help me do B, question B. Oh, Sophia's hand is up. Thanks, Sophia. Okay, so tell me, how do I expand this?
So the expanded form of this is 3/4.
What about the negative? Is the negative part of the base?
The negative is part of the base, so it could like cancel out.
Oh, you're right. But can I just write it for now, just in case?
Okay.
But I like how you were thinking. Hey, does it matter if I put the negative in the numerator or in the denominator?
No.
No, it doesn't matter. Okay, so keep going, Sophia.
So it equals 9/16.
Yeah, exactly, 9/16. When we multiply fractions, you guys remember that, right? You do numerator times numerator. So -3 times -3 gave us +9 over 4 times 4, which is 16. Nice, thanks. Now let's do the last one. Can you raise your hand if you want to help me do the last one? I don't know if I see all of you at once though, so hold on a sec. I don't see any hands. Oh, not a single volunteer? Okay, then you guys can watch me do this. That's fine. Well, the negative is not part of my base. It would be inside the brackets if it were. So keep the negative outside. Oh, really? I can see why no one wanted to help with this one. That's a big number. Hold on a
What's
second.
so bad about it, though?
Well, just the thought of expanding that. Watch. So the negative is there, and then I do 1/2 times 1/2. How many times is half multiplied by itself? Yeah? Did I do that? Did I get 5 halves? 1, 2, 3, 4, 5. Okay, excellent. Who can simplify that for me? You can just let me know in the chat. What's half times half times half times half times half?
Can I go to the bathroom?
Sure, who said that?
Catherine.
Sure, Catherine. Okay, excellent. And then there's one more step. You multiply the -1 times 1/32. Yeah, good. Very nice. Okay, so guys, you did really well with this part. I was going to talk to you guys about exponent rules, but I think you're ready for even harder math, okay? So now at this point, I'm going to switch over to Intro to Algebra, where you're actually going to see algebraic expressions. You're going to see variables, which are just letters in math. Okay, are you guys ready? We're making a bit of a switch. Is that all right? Are you guys ready for the switch? Yes, no? Yeah, okay, awesome. Okay, so like I told you guys before, algebra is math that deals with variables or letters. Okay, so let's establish this difference first. We have what's known as algebraic expressions versus algebraic equations. Algebra just deals with variables, which are letters in math. So what's the difference? What do you see as the difference between an algebraic expression and an equation?
The algebraic equation has the answer.
Oh, I see what you mean. Yeah, like there's an answer. In other words, it has an equal sign, right? That's the difference between an expression and an equation. Okay, so when it comes to algebraic expressions, we can't solve. You can't solve an algebraic expression because it doesn't have an equal sign. You can simplify it, you can do other things with it, but you can't solve it. Oh, you guys are already solving the second one. With an algebraic equation can be solved. Now
I just randomly decided to do the second one.
Yeah, okay, some of you are
Hey, did you
familiar with this. So wait a sec, what does it mean? I know some of you solved this, but you can't rush. Everyone's at a different level, so you have to kind of slow down and answer only the questions that I ask. Does that sound fair? Just because some people know this and some people don't, right? If you know this, that's really awesome, and it means that you're ready for a higher level, right? So what does it mean to solve an algebraic equation?
just solve an algebraic equation.
What does it mean, though? It means find the value of,
I forgot the word of, like,
in this
the
case,
answer. Like, I find the variable, yes.
yes.
Anyway,
Yes, it means find the value of the letter or the variable. In this case, find the value of x.
you
Find
still
the
get.
value that will make the left side of the equation equal the right side of the equation.
Sorry for just interrupting, but I think you should remind the students about the algebraic word evaluate.
Well, we're not doing evaluating expressions just yet. Right now, we're just talking about algebraic expression versus equation. But you're right, when it comes to algebraic expressions, you could be asked to evaluate. But my question was, what does it mean to solve an equation? And to solve means to find the value of the variable that will satisfy the equation. It will make the left side and the right side balance. And Olivia found the value. The value of x in this equation that you see right here is 4. When you substitute 4 into the equation, the left side is 7. The right side of the equation is 7. Okay, so the correct answer is 4. Okay, really good, everyone. Yeah, so you hold that thought about evaluating because that'll come later, okay? Let me make sure you guys know the difference between a linear equation and a nonlinear equation. Can someone give me an example of a linear equation? And if you don't know this, it's okay. I'm going to teach it to you, okay? But some of you might know this.
I don't know this.
Yeah, don't worry about it. It's totally okay. I'll teach you a little bit today, and then eventually, your teachers will teach you more, or I'll teach you more. Who can give me an example of a linear equation or a nonlinear equation? Maybe you guys don't know. Let me help you out then, okay? Look, a linear equation, well, an equation has to have an equal sign. So let me write this. 3x minus 5 equals 7. There's my linear equation. Now let me show you an example of a nonlinear equation. What do you notice is different between linear equation and nonlinear equation?
It has an exponent.
Hold on, Melissa. No. Sorry, guys. My son just wants to know if I walk the dog. Yeah, nice. Okay, I heard you guys say that. Yeah, it's okay. He's done. Look, you notice something about the exponents. Good. Here we have an exponent too. What's the exponent here with the linear equation?
I think.
Is it 0 or 1? What's this exponent? It's invisible, that's for sure. It's a 1. When the exponent is invisible, it's a 1.
Oh, is the 1 always invisible?
Yes. Yeah, you don't have to write the 1. If you don't see an exponent, it's a 1, okay? So, yeah, very nice. Look, with a linear equation, the largest exponent is a 1. With a nonlinear equation, the largest exponent is something other than 1. Okay? Now let's see if you understood what I said. We'll practice that. Okay, so let's see. How shall we do this? Well, question A is here. Here's the equation, everyone. 5x minus 3 equals 2 plus x. Is that linear? Is it a linear equation or non-linear?
It's linear.
Yes, thank you. Who said that?
Linear. Elena.
Thank you, Elena. That was good. You're right, Olivia. Good. It's linear because look, the exponent, the largest exponent on the variable on the x is a 1. Okay, what about question B? Is this equation linear? 2x minus half equals x over 7? Very nice. How come?
Because the logic exponent is a 1.
That's exactly how I would have phrased it. Perfect. What about question C? Linear or nonlinear equation?
Not linear because it has an exponent.
Yes. Not because it has an exponent, but the largest exponent is 2.
Yeah.
It has an exponent other than 1. It's a 2. See, there's a 1, but because there's a bigger exponent of 2, it's nonlinear. Okay, let's see. This is an interesting one. D, is that linear or nonlinear? Nonlinear, linear.
Non-linear.
You're right, it is nonlinear. Now, I know you might see an exponent of 1 here and an exponent of 1. I tried to trick you guys on purpose. But look, here's what you would have to do. In order to decide if it's linear or nonlinear, you would have to expand this. Look, this is how we expand. Some of you may know this, some of you may not. This becomes, who knows how to do this? Who knows how to use the distributive property to expand?
I know.
Who said that? Ellen, will you go ahead, Ellen, and expand this for me?
3x
Actually, I said it.
plus 3x times 2, which is going to be 6 x. So you add 6s, and the other side it's going to be 7x plus 5. So there is a square. So the answer is nonlinear.
Okay, who just answered that so beautifully? That was perfect. Alan, was it you?
Yes.
Okay, very well done. My goodness, you guys are doing algebra so well. You know so much. And look, the highest exponent is a 2. So this is nonlinear. Okay, so let me just make this point because some of you are doing so well with this and you've done this kind of stuff. But if you haven't, don't worry. You're going to learn it another time. Right now, I'm just showing a bunch of stuff, okay? Okay, that was really good. Okay, so now let's actually try to solve an equation. Let me explain this. I know some of you know the answer. You can just look at this question, yeah, and realize that x has to be 2, so that left side and right side, look, every equation has a left side and a right side, okay? LS for left side, RS for right side. But watch, because if this is new to you, then I want you to look. Well, in order to solve this equation, I want to be able to say x equals some number. Now, you guys knew it was 2 without much effort, right? But watch, here's how we do this. In order to isolate the x, to keep x on its own, I need to get rid of this positive 7. Well, here's the thing about equations. What you do to one side of the equation, if you do it to the other side, that maintains the equation. It maintains the balance. So in order to remove the plus 7, watch what I'm going to do. From both sides, I'm going to subtract 7. What I did to one side, I did to the other, so that maintains the equation. It's still left side and right side are equal. Now look what happens. X plus 7 minus 7. Well, 7 minus 7 is just 0. And then we have 9 minus 7, which is 2. I like to put a box around my final answer. Okay? So that's how we solve this particular equation. It says check your solution. Do you guys know what that means, to check a solution?
To put the number you got for your answer,
Put
and
the
then
number inside the equation and then check if it's actually correct.
Yeah, okay. I think 2 people were talking at once. Okay, so be careful about that. But you were both right. Very nice. Watch, I'm going to check my answer. My answer is 2. My answer is 2, right? Let me just write that here because it's getting kind of cluttered. That's my solution or my answer to the equation, right? So now I'm going to check. It's nice to tell your teacher that you're checking so they know what you're doing. So write check. You put a LS for the left side. What's the left side of my equation?
9.
Yep, but before that, it's x plus 7, right? This is the left side. Watch. This is the left side. It's to the left of the equal sign. Okay, so now I substitute. X is 2. So in place of this x, I'm going to put a 2 plus 7, and the answer is 9. What's the right side of the original equation? What's the right side?
我跟你说，CK 对你大儿子好，但是现在
9, right?
他都
What
不
do you
想
notice about the left side and the
这
right
个
side?
跟告诉我，
They're equal. That means we have the right solution.
没有经过证
That
实，
means x is in fact equal to 2, okay?
说这个那个你知道的，然后
Okay,
是
so
不真的信息嘛，然后那个 CK
okay, I want to show you another thing, but you know what? Maybe I'll do it with this question.
还跟他据理力争呢。但其
I'm
实
going to take Kevin's advice.
讲
Kevin has a
是
good suggestion about how to solve equations.
把他的那个
What I did was good, but there's a faster way. So watch.
我让他们先去了嘛。
So my goal is to be able to write
然后
A
CK
to solve
unmuted.
this. Yes, someone has to mute themselves, please,
Dragon Master，但是我等我看
because we
完了，
hear someone's mom in the background.
一个很好的善意 offer。
The answer is 15 because it's 12 plus 3.
Yeah.
我记得
So if you know this, that's awesome. But look, watch.
不好的书，然后
When I
说
move a number that's being added or subtracted to the other side, the sign changes. So from +3, move the, sorry, the -3 moves to the other side of the equal sign. What does it become?
I cannot hear you properly.
Yeah, guys, someone's,
然后
has, okay, I don't know who it is. Can you guys see who's not muted?
I think it's pronounced Lusa.
Or
不知道为什么呀？你儿子就这么怪啊？你不是现在，你不是也是那么怪吗？
Yeah, you guys have to mute yourselves. Okay, I think that's better now. Good. Did you see what I did, everyone? When I moved the -3 to the other side, it became a +3. So then I'm left with A equals 12 plus 3 is 15. And I solved for A. I figured out what A has to equal. Let's try another one.
Also, don't forget to double check.
Yes, for sure. If you have time, you always double check. Okay, look at this situation. Now I want to be able to solve for y. The variable I'm using this time is a y. I have to remove or undo. I have to undo what's happening to y. It's being divided by the number 5. What's the opposite operation to division?
Times multiplication.
Nice, good, multiplication. In order to undo the division, I have to multiply both sides by 5. Okay, that means 5 times both sides. And look what I get. 5y over 5. You can write it like that if you want. And these cancel out. Do you see that? And then 5 times 10 is 50. Put an arrow to let your teacher know where you're going. Y equals 50. Yeah, when Kevin says go backwards, what he means is you go in the opposite direction of bed mass. So that's very good, Kevin. Okay, so let's do this now, everyone. In order to solve for this, gradually my equations are getting a little more complicated. Not very complicated, just a little more complicated. The goal is to put all of the terms that have a y on one side of the equation and all of the numbers. What do we call numbers in math, by the way? Starts with a C. When it's just a number?
Exponent or something like that.
Yes, very good. I think you said something.
But basically, you have to take all the variables to one side and the constants to other, so that way it's going to be easier for you to solve the problem.
Exactly. So let's do that. The 5y will stay where it is. What happens to this -4y when it moves to the other side of the equation?
Turn into a positive.
Positive 4y. Okay, good. Hold on. The 6 will stay where it is, everyone. See this 6? Let's keep it where it is so it doesn't change at
Is
all.
the answer -9?
Oh, I don't know. I'm not that fast. Goodness. Okay, let's move the 15, the positive 15. When we move it to the other side of the equals, it becomes the positive 15 becomes the opposite of positive 15, which is
A negative.
negative.
Negative 15.
Thank you. Good. Okay, now look, these are like terms. These are like terms. We can combine them. What's 5y plus 4y?
9y.
Oh, you guys really do know a lot of algebra. What's 6 minus 15?
The answer is it's
Negative 9.
-9. So the answer is -1 for y.
Yeah, okay.
And
So I'm really happy a lot of you know this, but you know, not everyone knows it. So, but don't worry, if you don't know this, you're just absorb what you can, and in the future you'll learn this some more, okay? So don't get intimidated if you're one of the kids that doesn't know this yet. You'll learn it soon enough, okay? Okay, so
Is this grade 5 math?
no, actually, guys, I think this comes up in like grade 8, definitely in grade 9. So I usually teach this in grade 9. Okay, so now listen, watch. This example has an equation unlike any that we've done before because it has brackets. So the goal is to remove those brackets. I know some of you know how to do this. It's called the distributive law. Watch. See 4 and then you have bracket, bracket. That means 4 times everything in the brackets, okay? So I like to use little arrows to help you guys. If I can get one person to help me with this so that not everyone is speaking at once. Who would like to help me? Oh, I can't even see. Hold on a sec. Maybe just raise your hand or give me a sec, guys, because I can't really see everybody at once. I have to figure out this Zoom thing. There are some students that haven't contributed yet. Is there anyone that hasn't really contributed that wants to help me? No? Okay, do you guys want me to do this on my own?
Like 2 people raising their hands.
Oh, who is it? I can't see them.
Jason and
Oh, I see now.
Lee's iPhone.
Oh, Jason and Lee's iPhone. Okay, so maybe we'll start with...
and Alan.
Oh, thank you. Now I see your hands. Lee's iPhone. You'll help me first, okay? And thanks, Jason. I'll get you next.
12 minus 8x.
1 sec. 4 times 3 is 12. 4 times negative 2x is negative 8x. Do I have to multiply 4 times this 5? No, because the 5 is not in the brackets. So plus 5. Keep going.
3x minus 12.
Nice. 3 times negative 4 is minus 12. Okay, so now let's do what we did in the last example. Let's put all over x terms on one side, all of our constants. Those are just the numbers on the other side. Jason. Oh, I know, Catherine, you must be tired because this was a lot of new math for you. And it's your birthday, so, but you did well, okay? Don't get discouraged. Jason, can you help me out? Can you put all of the x terms, all of the terms that have an x on the left side, and then all of the constants on the right side, Jason?
Okay. So, the constants would be 12, 5.
Oh, which is fine, but I like to keep the x's on the left side sometimes, so
Oh, okay.
do
So,
you mind?
yeah, 8x
Yeah?
and 3x.
Oh, put this positive 3 onto the other side. It becomes
Constant.
the positive 3x. When it moves to the other side, it becomes a negative 3x. Yeah?
Okay.
Okay, and now deal with the constants, okay?
Okay, so the left side, there's negative 12, and the other side, there's 12 and 5.
Oh yeah, the 12 and the 5. See these 12, the number 12 and 5, everyone? This number 12, and this positive 5. 12 plus 5, what is that anyhow? 17, right? Let's move
17.
the 17 to the right side. What does the 17 become when it goes to the right side?
A 5.
So 12 and 5 is 17. Positive 17. When we move the positive 17 onto the other side, it becomes a negative.
Oh, a negative. Yeah.
Yeah, negative 17. Very good. Okay. Do you want to keep going, Jason?
Okay.
Are you good
And
with
then,
this?
yeah, that would be negative 11x
Yep.
equals negative 29.
Yeah, very nice. You're not quite done. One more step. Hold on. Let me make my screen a little larger. I have no room.
Yeah. And then you would divide by negative 11 on both sides.
Yep, you guys can see that, right? These cancel out, and you're left with x equals... It's a fraction. We can leave the fraction as 29 over 11. I just want you to simplify one thing. See how we have a negative in the numerator, a negative in the denominator? We can simplify that. What does a negative divided by a negative become?
A positive.
Yeah, very nice, Jason. Good work. So that's our answer, everyone. We solved this equation. Okay, thanks for that. Are you guys ready for a word problem?
Yes, and just to tell you, for like these types of equations, usually if they're both on like if you have just wanted to like really work on consonants,
Constants,
or
yeah.
the variables, if they're both negative, then for me, I would probably like put the bigger one to the other side.
Oh, I see what you mean, yeah.
So if one's positive and one's negative, put the negative to the other side, then it makes it the positive, and the positive plus the positive is equal.
Yeah, who was speaking just now? Who just explained that? That was kind of cool.
Me,
Who's me?
Alan.
Okay, very nice, Ellen. You know what Alan was saying? Jason, I think you tried to do this. You know how you wanted to put the negative 8 onto the other side, making it a positive 8? So that would have been cool. Then we wouldn't have to deal with this negative 11 here. So that's kind of cool. That's neat that you noticed that. It's not something that you can easily explain, but you did a good job. Okay, let's do this. Let's end on a word problem, because algebra and word problems go hand in hand, okay? So look, 5 added to 3 times the number is equal to 113. Find the number. Now let me say this, don't tell me the answer. I don't want to know the answer. Find the number. When you get a word problem, you have to introduce your variable. I'm going to let my x be the number. Okay, that's called introducing your variable. Let x be the number we're looking for. Almost done, guys. Just a few more minutes and then we'll be done, okay? This will be our last question. So
Then I have to go to bed.
5 added to 3 times a number. How can I express that with an algebraic equation? What's 3 times my number? If my number is x, what's 3 times my number? How would I express that with algebra? Oh, nice try, Amy. Not to the power of 3. Yeah, 3 times my number is 3x. 3x means 3 times x. And now we have to do what to 3x? We have to add 5. Okay, good. Add 5. Very nice, Alan. Very nice, Gary. And that is equal to 113. Okay, when you get a word problem, you always have to introduce your variable. you set up an equation for these types of questions, and then you have to solve your equation. So let's quickly solve this.
Is X 36?
I'm not sure. You guys are really fast. Let's move the
Okay.
positive 5 to the other side. What does the positive 5 become when it moves to the other side? Negative 5. Nice.
A negative 5.
Yeah, so what's 113 minus 5?
108.
Yes. And now I'm almost done. But look, I have to remove the 3 that's being multiplied by x. To remove or undo the multiplication, you divide both sides by 3, okay? And x equals,
36.
is it 36? Okay. What's the one last thing? When you're given a word problem in class, what's the one last thing your teacher wants to see?
Sentence?
Yes, a sentence, a concluding sentence. Therefore, the number is 36. And there you have it. Okay, guys, can I just ask you guys in the chat, let me know, was this something was this easy? Was it, let's call it easy, so-so, or hard? Those are your options.
Hard. Me.
Let me know in the chat, easy, so-so, or hard. And it doesn't matter. It doesn't mean you're bad at math if you think it was hard. It just means you haven't learned it yet. Okay, for a lot of it was, oh, we even have the too easy. Yeah, Catherine, don't worry about it. You're so young, you haven't done this yet. So, Amy thought it was so. Lee thought it was too easy. Catherine said hard. Another so, too easy. Okay. Yeah. Yeah, see, everyone was coming from different levels, but you guys did really well. Thank you for being here with me and participating. Thanks very much, guys. So have a good rest of the night, okay? And enjoy your long weekend.
Okay, bye.
Okay, bye.
Okay, bye.
Good night.
Bye.